just a little bit of background, and I'll be cognizant of the time so that we finish up with plenty of time for questions. This is one of those presentations that, having given it before, its intent is to answer some pretty basic questions about the problems that we face as rescuers in backcountry radio communication. But as with a lot of presentations such as this, sometimes it almost brings up as many questions as it answers. So we'll go through this and keep note, send your questions in through the chat window, and we will make arrangements to be certain that they're addressed as we go through. Just to give you a little introduction into myself, my name is Paul Robertson. This is my 4th year on the Grand County Search and Rescue team. I am a member of the board of directors. I am our SAR Academy. That's how we bring our newer people in our process. I'm the coordinator of that. I, in January, was elected or began my term as field director, so I'm responsible for all field operations of Grand County Search and Rescue in Grand County, Colorado. And I am a ham, I do hold a ham technician license, so that's sort of that's how I got involved in the whole let's solve these radio issues. Again, by way of introduction, last June I gave this presentation at the National Conference in Estes Park, Colorado, which is only a short drive from my house. This was literally the road over the top only 3 weeks before I made that trip. There's the visitor center completely under snow. And I want to touch a little bit just on the timeliness of this whole thing about expanding how we think about using radio. Just prior to the national meeting on Sunday, May 17th of 2015, Grand County Search and Rescue and Alpine Rescue helped a 59-year-old Littleton, that's a suburb of Denver. He was up on one of the peaks. He's a ham radio operator who does what we call summiting. So he climbs to the summit of local landmarks. In this case, they're pretty prominent, primarily above 12 to 14,000 foot summits, and he sees how many people he can document contacting. So he happened to get caught in a windstorm, was in a complete whiteout, walked off a cornice, fell about 30 feet. Luckily, there was plenty of soft snow for his landing. Also, luckily for him, he gripped his handheld tightly as he stepped over the edge. So when he landed, he was not injured, but he had his radio in his hand. And so he continued to maintain contact with a ham radio operator who then contacted by way of relays both our team and Alpine Rescue. Being at the top of Berthoud Pass, he was right on our borders. So it's kind of an interesting way that ham radio got tangled into a normal search and rescue. So here's basically the problem that we had and how my research sort of led to all of this information in our solutions. We had a growing membership. About a year ago, we added another 20 members to our team. We're funded, like most search and rescue teams, by the Sheriff's Department and fundraising and that sort of thing. So the idea of going out and buying 20 new radios at somewhere between $300 and $500 a piece was not really a viable solution. So we started to search around, I did in particular, and how could we save money in buying these new radios? Is there newer, better equipment? And then also having to figure out, while we're acquiring new equipment, let's take into consideration the difficulties involved in backcountry radio communication. And our two main problems are these, and probably pretty common to most search and rescue teams, and that is our repeater. We have a dedicated repeater in Grand County, just called SAR Repeater. It's privately owned and donated to the use of the team. It's a fabulous thing, but it doesn't work everywhere. So the one thing that we always have to find out once we field is that SAR Repeater doesn't work here. And simplex, that is just normal radio-to-radio direct communication, may not go up a canyon, over a peak, and those sorts of things. So it really kind of presents an ongoing problem for us. So then we have to think about, what are the actual problems? In other words, the radios, the problem may not be the hardware. What's available to us is commercial radios. The problem may not be the frequencies. They're assigned to us by the federal government. So there's a lot of different things to think about when what are the actual problems that we can solve while we're purchasing new equipment. Let's keep that in mind so that we don't buy something that just continues the status quo and doesn't address these issues. And how can we modify either our equipment, our techniques, or our communication protocols that will solve these main problems? And that is, basically only two things. I can't reach the repeater, or I can't hit simplex team member to team member up a valley or over a peak. So I'd like to spend a little bit of time, and I'm not going to dive deep into it. I'm not a tinfoil hat sort of radio operator, but I do want to, just like our medical director believes that if you've got a firm fundamental understanding of cellular biology, it will help you in understanding what's happening to your subjects as they go through a hypothermic experience. I do want to spend a little bit of time on how radios actually work. So we're going to talk a little bit about radio waves, the frequencies, the bandwidth, just a little terminology, and wavelength. These are things that you'll get involved with, even a little bit if you're just taking a look at the systems that you have in place, in particular if you're buying new equipment. We're going to take a look at the actual power, and that is what is the power of the signal that's coming out of the radio. Handhelds by law are limited to 5 watts. Mobile, that is permanently installed in a vehicle, operates at 50 watts. And keeping this in mind, that is transmitting power. So how are we pushing the signal out? The reception of a signal is a passive event. And so that will have more to do with the protocols, technology, and that sort of thing that are involved in the antennas that are attached to our radios. So we'll talk a little bit about that as well. And that leads to the next thing, and that is antennas. So we need to think about the waves that are flowing through the air. We need to think about the power in which they're being pushed out of the radio. And we need to think about the antenna, because that's how we're getting these signals in and out. So just a little, very, very little brief synopsis of radio waves and frequencies and that sort of thing. You can see sort of in the middle of this chart is VHF. That's where we spend most of our time in radio communication. These are commercial bands. Typically, with what we do, they're centered around 150 to 155 megahertz, somewhere in there. You can see that UHF is our other frequencies, and that's typically where our DTRs or 800 radios are operating in the UHF band, and that is a completely different set of frequencies. And then you can see that way up on the scale, on the far right, we go into infrared and then visible light. Wavelength is literally, and this gets to be interesting when we think about the design of antennas and what we're putting into place here. So it really is pertinent to what we're talking about. The wavelength is literally, think of waves coming into a cove. It is literally the distance between peak to peak on the radio wave that is being transmitted or received by the radios that we have in place. And you can see here's just an example of low frequency. It's exactly that. There's a long wavelength between medium frequency and high frequency. This also gets to be a little bit of importance in how these radio waves make their way around the world. That's why a shortwave operator in the really super bands can be talking real time to somebody in Europe, because those waves act differently. For our purposes, we think of line of sight. They can power through buildings, as you know. They can power their way in and out of our automobiles if we're sitting inside with a handheld. But for our circumstances, we're not talking about a radio wave that bends around the Earth or necessarily bounces off the ionosphere or any of that sort of thing. So again, here's just sort of a little quick summary of what these frequencies and wavelengths. You can imagine, again, if you shorten the wavelength, you're increasing the frequency. You saw in those jiggly little lines that if we increase the frequency, we're going to shorten the wavelength. Again, not so important, but if you look down the way a little bit here in very high frequency VHF, you can see that the wavelength is 1 to 10 meters. And this really shocks people to think about the fact that that radio wave, that wavelength is literally 1 to 10 meters in length as it's coming to us. This only gets to be important in a little bit when we talk about antennas, but that was a shocking thing to me when I first got into all this, to think that a radio wave that I'm talking on a radio could be a 10-meter length. So how do radios actually work? Again, here is why the radio wavelength gets to be a little bit important, and this will have very practical implications, I assure you. So this is the simplest antenna that there is. We string a piece of wire horizontally. We attach a piece of wire in the middle of it. That drops down, you can see here, on a coax cable and goes to our transceiver, either our handheld or our mobile in our house or whatever. And so what happens is this. Here's an idea, and this is where I'm kind of trying to put this all together. So here's a radio wave coming over an antenna, and you can see that if that wavelength gets to be a meter long, and we were designing our antenna to be a quarter wavelength on each end, now you can see where it's relevant. And this is why when we take a little short little rubber duck and stick it on a handheld and put it on our chest harness, and it sits at an angle, we're already starting to compromise all kinds of things. So in an ideal world, we would carry around big, giant, long pieces of wire, string them horizontally, and it would operate like this. But that's not how things work. We turn them vertically for one thing, and what that does then is it puts that radio wave out. Think of this like a big donut. So on your left, you can see there's a vertical antenna, and it's pushing this big donut, and the further out you go on that is actually how powerful the power of that communication capability. This is how it looks if we were out in space, and a lot of this is theoretical. This is how it starts to look if we're standing on the ground. And so we need to think about this when we're thinking about repeaters that are on mountain peaks, when we think about trying to push our communication up a valley or to a peak or down into, so this gets to be actually real. But this is what it looks like when you're standing on the ground, holding a radio in your hand. You're putting out these big half donuts and it's at its most powerful. In this case, you can see it's going out at about a 30-degree angle. So again, not getting too caught up in it. So what could we do then? If this is, we're trying to enhance this horizontal plane. So you'll see antennas on top of people's houses that look like this. So those little 3 wires to stick out are called the ground plane, and they help focus that radio wave and squeeze, for lack of a better way to put it, squeeze that donut and push it out. So that's what it would look like if it was on a pole next to our house. Interestingly, when you put a magnetic-based antenna on the roof of your car, the metal roof of your car, provides that horizontal ground plane. So that's another way that things really get enhanced when you're using mobile. So we can think about antennas. Remember, this is where the whole wavelength thing gets in, because when we purchase antennas, we can get a full wave, a half wave, a quarter wave antenna. 5/8 is kind of a little thing that we play with in between. But here's why that gets to be significant. Oh, and I'm sorry, a J-pole, which is a specialized antenna that I use to great effect out in the field. So this is kind of the difference when we look at squishing this donut. So if we look at one of these envelopes, if you think of them that way, a full wavelength antenna, which unfortunately in the field would be a minimum of 3 feet long and would go up from there, is the one that pushes out the furthest. The compromise then we start to see at a 5/8 wave, and again this just gets to be a matter of what sort of antenna are you buying. Quarter wavelength obviously is shorter, so if you want a little short stick on the end of your handheld, that's where that gets to be appropriate. But as we change the length of our antenna, or the effective length of our antenna because of how they're designed, you can see that we're pushing more power out horizontally, and that's the whole idea if we're trying to talk on a radio. Here's kind of a little more practical view of that. It's kind of dumbed down a little bit. The big round circle coming off from the center to the right and left is a quarter wavelength, and the 5/8 wavelength pushes out. You can see how far it pushes out horizontally, and then there's kind of a weird little interference lobe that goes up at about 60 degrees. But the point is this, is that we can change the design of the antenna as a functional length compared to the wavelength. I know it gets a little deep, but stay with me here. And it makes a tremendous difference in the field in how effective we are at pushing that out. This is kind of a joke. Here's how you could figure that out. This, again, is a very practical picture. So here's somebody standing on the ground. The perfectly round donut that we saw in space is getting squished a little bit. And you can see that a 5/8 wavelength versus a quarter wavelength, how we might want to be pushing that radio signal out. And again, here's another very practical kind of view of this. On the far right-hand side, we've got a repeater, or maybe that's somebody standing, one of our teammates. And you can see that as you go from a 5/8 to a quarter wavelength, the angles change tremendously, and this allows us to for lack of a better way to put it, kind of focus the power that's coming out of our handheld. So how do repeaters work is the problem here, is that if we put a repeater on a tower, radio waves are just like waves on the surface of a pond, or sound waves if you were shouting. They're going to get blocked by the terrain. And as you can see in kind of the lower right, this is why sometimes one person can hear a signal and another person can't. As those signals go over a geographic barrier or geological barrier, it does kind of cut them up into pieces. This is why sometimes, quite literally, if you have been able to talk to somebody and now you've lost them, it is almost worth it to walk 10 meters in one direction or another and see if you can pick them back up. So this is, again, another kind of a practical image of how repeaters work. We've got a person on the lower right with a portable handset with direct line of sight to a base. They're talking to it. The base is going up to the repeater, which is on the mountaintop, and the mountaintop can go either back down to a portable or to a mobile. But in any sheriff's department or public entity, I'm sure that all of your teams have repeaters that are provided in some fashion for you. And so you're hitting that, we talk about hitting the repeater in order to be able to maintain communication where the geography would not permit that. And again, I'm going to step not too far in the weeds, but a little bit in the weeds. A repeater is actually just a receiver and a transmitter that are in the same location, and they work simultaneously. So when you program your radios, they're actually different frequencies. The transmit and the receive are slightly offset so that they can work simultaneously. This is why this is typically on a tower. It's a whole bunch of equipment. It costs a lot of money. It needs to be maintained. But that's why if you're talking one to another directly, you talk on the same frequency. And when you're using a repeater, think of it as, you know, when you're holding a telephone handset to your ear and mouth. Think of it just like the earpiece is one frequency, the mouthpiece is another frequency, and this allows you to do it simultaneously while you're in the field. So that being said, one of the things that I did when I first kind of took over things like this is take an actual look. This is just Google Earth, and it was kind of fun to play with. So this is our repeater that we use for Grand County Search and Rescue. And you can see that what I've done is draw a line to one of our more popular IC points for missions. This happens to be a very popular snowmobiling and ATV trail system. There's a huge trailhead there for us to organize. And so just for coincidence, because I wanted to start putting some practical application and getting my teammates to understand why they sometimes can hit a repeater and why they can't, I simply went to Google Earth, threw a pin in where our repeater was, drew it out to the trailhead, and then you can look at it horizontally, and you can see while there's plenty of terrain in between the two, you could in fact draw a line in that horizontal chart from the left side to the right side without an obstruction. So that would show us that that repeater will work in that location. Here's another one that goes from SAR repeater to actually a location that's significantly closer. But as soon as you drive around the road that curves around this little peak that you see on the far right, you lose the signal, because you can see that if you went from the far left to the far right of that elevation diagram, you've got an obstruction in between. So is it necessary for you to go out and do all this? No, this is just something that was kind of a learning aid that I provided for our team. But it does make it very clear that, repeater or not, this is why sometimes you cannot communicate with one another. Because remember this, is that if I'm talking to you and we're both using the repeater, we both have to be able to hit the repeater. So maybe you are used to using a repeater from a particular location, and I happen to be in a different location. Unless we can both hit the repeater, even if we're standing right next to each other, we're going through the repeater. So in this case, I could be behind that obstruction, and you could be standing 100 meters away from me, also behind the obstruction, and we cannot talk on the repeater. Also why in a sheriff's department, if they're using an 800 system, there are typically multiple repeaters that are coordinated. That's why it's called a digital trunk radio, or DTR. It's coordinated electronically. This is also unfortunately why there's often some delay in using a DTR or an 800 radio, because these signals are being processed from sometimes multiple tower locations and all being kind of mixed together and shaken and then poured out into an earpiece so you can hear. So this is one of the ways that on a practical basis we're affected by, we see a change in availability of a repeater as we move geographically. So we have to have some practical solutions. Again, the equipment I have is the equipment I have. It's either what's available commercially or what's been provided by the Sheriff's Department. If it, the frequencies and the wavelengths, although that's interesting to see how that affected our antenna, and that's the only reason I brought it up, is because we do have choices in that, and we'll get to that in a moment. But so many things are set. The equipment is what we've got. The frequencies are set by law. The power of our equipment is set by the federal government. There's really nothing that you can do to get around that. So this is why I started looking at what are the practical solutions that we can put into the field. And the first thing that I did, and that most teams can do, is investigate what's called a tuned or a frequency-specific antenna. And this is where we went through the little exercise of looking at what a wavelength is, and why if you've got a 1 meter or 3 foot wavelength and you've got a stubby little rubber duck on top of your Kenwood or your Motorola that came with it, it's not the best antenna in the world. First of all, when the manufacturer produces that antenna and they produce that radio, they don't have any idea within, as long as you operate legally, what frequencies you're going to be operating on. And if the antenna needs to be able to pick up all of these various frequencies, as we've seen, that would be a function of the length of it. There are compromise after compromise after compromise. The minute they try and put an antenna on a radio that's going to be used across a great spectrum of frequency. So this is why some of us laugh that the rubber duck that comes with most handhelds, you may as well just stick a potato on. It varies team to team, but you most likely, as we do, operate about 155 megahertz, 156 megahertz, and there would be a point something 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 after that. In other words, we focus our attention in the MRA channel antenna to focus its attention. It works on all of them, but it's, if you focus your attention by the design of it on these frequencies which you are most likely to use, the efficiency and therefore the clarity and the power of these antennas increases in magnitudes. So that was the first thing that I explored internally on our team, is buying and experimenting with with antennas that were tuned. In other words, they were center ranged at 150 or 155. And we'll talk, and it made just an enormous difference. When performance of antennas are measured, it's one of these things that, if depending on your experience with such things, it's exponential or logarithmic. In other words, if I go from a 2 to a 4, that's not double, that's quadruple. If I go from a 3 to a 6, that's a factor of 9. So when you start to see some improvements in the antennas on an oscilloscope, or the technical terminologies, the difference that it makes in the field are really quite enormous. So I experimented with some tuned frequency-specific antennas. They're not necessarily any more expensive than a standard antenna. The ones that I buy, and we could talk about this later, are in the middle $20 per antenna range. Interestingly enough, I was just down in El Paso County, which is, think of Colorado Springs, Colorado, doing their MRA recertification weekend. And some of them had been at my presentation in Estes Park last June, and I looked around at people's radio chest packs, and a certain number of them, in fact, have put these antennas on their handhelds. The next thing you can use is something called a counterpoise, or a rat tail. Easier seen than described, so I'll just we'll get to that in just a moment. A roll-up dual band J-pole is just another type of antenna. The fact that it rolls up means that I can literally think of this as something that's a piece of special wire that's maybe 6 feet long, but it's so flexible that I can roll it up and stick it in my pack, and it has an attachment on the end that allows it to replace the antenna on my handheld. And then, of course, just hitting repeaters and thinking about that. So here's a frequency-tuned specific antenna. These aren't to scale, but the big difference, and you can see a little bit here in the length and the design, the one on the left is a 1/4 wavelength, the one on the right is a 5/8 wavelength. The difference, in fact, practical difference is one is about 8 inches long and one is about just short of a foot long, 11 inches long. So it isn't one of those big long ones that you see people putting on the Chinese radios that they bought on eBay to use on their team, you know, where you've got a 15 or 16 inch whip. This is the physics, that is the ability to acquire the radio signal. This is the equivalent of a longer antenna, but because of its design, it's shorter. It's not just chopped off like a duck. It's just designed to be tuned specific to those frequencies. But I have to tell you that when I put one of these on my handheld, the difference in the field is staggering. I mean, to the point when I was monitoring all the radio communication at the El Paso recert, and depending on the radio, if we had done a debrief about radios at the end of those exercises, I probably could have gone around the circle and by call number tell them what kind of radio, what kind of antenna they had in their chest pack, because the difference in performance of what they were putting out versus what I could hear was substantial. So the point is this: for a $20 to $25 per antenna expense, we can significantly change the effectiveness of the radio communication out of that VHF pack set that we carry on our chest pack. On a practical basis, I would suggest that you try one or two, see how they work. Contents may vary. The rat tail or counterpoise. This is something that I found once I got more immersed in the whole ham radio, and this is why they call it a rat tail. So there's a handset with a typical kind of rubber duck antenna, and the counterpoise, or the rat tail. Remember the first diagram when I said the simplest, most effective antenna would be we just string a long wire horizontally and we attach our radio connection in the middle. That's essentially what we've done here. So you can build these rat tails so that, they are built to a specific length. For my frequencies up here, I run about a 19-inch rat tail because that, guess what, is a 1/4 of a wavelength, or rather a 1/2 of a wavelength. if you figure 18 times 18 is 36, that's about a meter. We're using all round numbers here during this presentation. But I have approximately a 19-inch rat tail, and it fits somehow in between. I'll show you a little bit of detail. That's sort of how you can see. It depends on the radio, but it is quite simply a piece of wire that you can buy at Ace Hardware, connected to a connector that you can buy at Ace Hardware, and squished with the pliers that you can buy at Ace Hardware. And this dramatically changes, or can dramatically change, the effectiveness of your handhelds. And you can just leave it connected all the time. You don't have to take it on and off. On some radios, the screws that hold your little clip on the back are in fact live, that is electrically live, connected to the chassis of the radio. So rather than putting it in series with the antenna like this, I've literally just taken off my belt clip, stuck this underneath, screwed my belt clip back on, and it works just great. So this, in fact, provides the same thing as that really efficient, simple antenna. So now your radio is in the middle of this. What handheld radio manufacturers count on is your body holding the handheld, providing some kind of ground plane like this. The problem is we're mostly water, we're not mostly wire, so it's not particularly effective, but it's the best they can do when you're holding a handheld. But there's all kinds of YouTube videos on this, and if you just Google rat tail or counterpoise, you'll be up to your neck in information and how to, I mean, this is literally a 50-cent improvement in the communications quality of the radio system that you have in place. This is that roll-up dual band J-pole antenna, and you can see there's the little fitting that goes in place of your antenna, so you just unscrew the antenna off of your radio, you screw this on. This is, depending on if you were in college in the 70s like I was, and you had a receiver and you wanted to get FM, and you remember those little flat twin wire T antennas, they were T-shaped, and you screwed them onto 2 screws on the back of your receiver, and you thumbtacked them onto your dorm room wall. This is that same material. So the material itself is relatively inexpensive. You can build these yourselves. I wouldn't suggest that. The measurements are quite critical. These are available from a particular guy on eBay for under $30. He's a physics professor at Berkeley. He knows what he's doing. You can order them tuned rather than just say, I'm a ham radio operator, I want one of these. You can say, I'm commercial, and he'll tune them again, center tune them to that 150, 155 megahertz in there. This thing is astounding. I have one of these just thumbtacked in front of the window of my home office, and I can put this on the top of my little handheld that I carry on missions in my chest pack, and I can hit a repeater that's 27 miles away with geologic obstructions in between. So this dramatically, so imagine this, you're in the field, it's getting a little scratchy, you pull this out, you screw it on the top of your radio, you take a piece of paracord, you tie one end to a rock, you throw it up in a tree branch, this thing's about 6 feet long. You can buy extensions of that coax cable, and you could drag this thing 30 feet up in a tree. So not only is it tuned to your frequency, it's running about 6 decibels, which is going to be somewhere in the neighborhood of 4 to 6 times better, more efficient, and you've just hauled it 30 feet up into a tree, which changes your horizon tremendously. So this is a terrific tool for teams to explore. It is literally $30 on eBay from this particular guy. So the last solution that I wanted to work on for our team was repeaters. If the county repeater, like you saw the one that I measured out on Google Earth, and that's our big one, sits on a tower, but what if I'm just working over a particular peak? I've got commands set up, I've got teams that have now ascended and descended the other side. Well, what if I, without having this big fancy tower and power supply and duplexers and all this equipment, what if there was a way that I could connect these 2 radios over a peak? And this is the solution, one of the solutions that I was exploring, and works actually very, very, very well. Some handheld radios have the ability to what they do call a cross-band repeater. This is how they get away without having a duplexer, which manage that simultaneously transmit and receive and blah, 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 all that sort of stuff. So your person in the field could be the left-hand handset running on standard VHF. You could have somebody standing at a peak, a summit, in between your IC and them with this crossband, their radio set up with crossband repeater functionality. And typically you go into the menus and you just say do it, and you tell it what two frequencies, and you're done. And then because it's crossband, in order to get away from all this duplexing equipment, it has to come in UHF and go out VHF or vice versa. But if in your command vehicle you had a handset that was capable of this, or you had a mobile radio that was both VHF and UHF capable, you could run this, and essentially we're making a repeater that can be hand carried by a team member. So then I started thinking, well, if we did that, what if we did something like this? So there is a frequency-specific extendable. This is an antenna that is sold to a lot of border patrol people because they're doing great distances. But what if I took that little handset and I put it in a box and attached even a better antenna to it? And here it is kind of popped open. So you can see that all I've done is connected the antenna that's outside the box to the antenna that's running on my handset. There's a little 12-volt gel cell in there. I kept things very simple. There's a battery eliminator, and I even kept a little 12-volt cigarette lighter plug just for versatility. So now what I've done is basically taken this scenario where I've got a handset with that kind of capability, put it in a box, and I can use either that straight extendable antenna, or there you see a rolled up J-pole, and put that out into the field. So now the reason that I wanted to kind of go through these things in this order is we're stuck with the handset we have because we already own them, or it's what's available commercial. We're stuck with the powers, that the transmitting power, because that's regulated by the government. We're stuck with the frequencies because that's regulated by the government. And we're stuck with the geography that we have to face day to day in relation to the repeaters that are provided by our county entities. And so basically what we do is take a look at what can we change. And what we can change is look at these tuned frequency-specific antennas, look at a rat tail to improve the efficiency of even these tuned antennas. We can look at a J-pole, which is more of a, obviously you're not going to drag that out of your pack while you're on the move, but once you set up camp somewhere, you drag that up in a tree. Or then we even take, if situation warranted, a little portable repeater. I mean, I could literally, this is a waterproof plastic ammo box that you could buy at Cabela's. You could literally chain this to a tree and it would run for days if it had to. I should have this caveat. If you're going to do this, somebody on your team should be a ham radio licensed operator. I'm just saying. But the point is that what we've done here is kind of tried to overcome all of the problems that you face and that we faced. And this was some really terrific solutions. So now we're kind of at the point where if you've got some specific questions, and I don't know if we're going to run off the list of questions that have come in, or if you are opening up mics. I'm not sure how you all run this.
We'll actually just have the audience type the questions. So
Okay,
if you have any questions, go ahead and just type them into the questions or chat/question section of your control panel, and then I can read them off for Paul to answer. And we haven't actually received any yet, so I'm just going to give you guys a couple of seconds here to go ahead and type your questions in.
And I'm wondering too if it would be advantageous. I can put out a source list. Jessica, if you would can forward that to participants, or if we have a mechanism to get that out to them so that they could see, well, where commercially can I buy one of these antennas, or that sort of thing.
Yeah, absolutely. Okay. We can, if you can send that to me, we can post it on the website with the presentation.
Perfect.
Okay, so the first question is, how do you determine the length of the rat tail?
So you determine the length of the rat tail, and this is why, again, I said, maybe we should I'll source these out, because it's very simple math you can do on a calculator, because you want that rat tail to be 1/2 of a wavelength. So we would take your frequency, that's why, without going through the math right here, but it's very straightforward. If I was looking at a 155.6, because that might be my most used channel, or if you wanted to tune it close to MRA 1 or MRA 2, for example, it's a very simple, you can run it on a calculator. It's very difficult to enunciate, but you literally just punch a couple numbers in, take the frequency times this divided by that will give you the length, and then I just convert that from decimal to inches, or rather metric to inches, and in this case, for my situation, it was 19 inches. So I take a little flexible multi-strand, 8 gauge or 12 gauge wire from Ace Hardware. I cut off one end of it, strip it clean, put the little connection lug on it, and then I measure out from the end of the connection lug, figure out a little bit of fudge factor. I think we figure out about 5%, and I just cut it with a wire cutter. And in my case, I run about 19 inches, and it makes a pretty big difference.
Okay. The next one is, could you talk a little bit more about tuned antennas? How tuned should they be if you're working in an area with multiple frequencies?
Well, luckily, they're not as specific as, what we're doing is, think of it like a bell curve. And what we don't want to do is have a bell curve, think of it like a bell curve versus a flat horizontal line. And so the antenna that comes from a manufacturer, they're either guessing where you're going to use it, or it's such a piece of junk that it's just a flat line. In other words, there's no real emphasis on efficiency. And unfortunately, if we thought of efficiency as the vertical component of that bell curve, it's not particularly efficient at all the way across the board. So, for example, if I were to order an antenna, if you were to say 150 or 155, you're not going to be tremendously compromised, and most of us are going to operate if you took a look, if you talk to your comms person on your team, most of the frequencies that I'm running on my handset with my team, and I'm doing a combination of my repeater, simplex channels that we just use amongst ourselves, MRA 1, MRA 2, and some of the public safety frequencies that we use here in the county that are available to me. That width is not very wide at all. Maybe 150 to 156, because you can run to 3 decimal points. So the point is, don't get too caught up in it. Just when you talk to the people that I can put you in touch with, it's one particular antenna company. Their service is phenomenal. They sell to search and rescue teams, Border Patrol. As they've increased the number of offerings, it can be a little confusing, but they're happy to take a phone call. But you would be perfectly fine to just buy one that was, say, 150 or 155, and that would be perfectly fine. It would just, all I'm saying is that we're taking it from a horizontal efficiency line and putting a bell curve in it, and that the top of that bell curve is somewhere near where you operate. But you're only going to be able to make a distinction when you buy them in maybe 5 or 10 megahertz jumps. So you're going to go maybe 150, 155, 160, 170. But it'll be pretty apparent if you look at the frequencies that are programmed into your handset. It'll be pretty obvious where you want to be. And it's not that they're so much better even on the ones that they're not tuned to, because of the quality of this antenna, that it's never going to be a compromise on the ones that it's not tuned to. It's just going to be significantly better on the ones that are nearer the center of that bell curve.
Okay. And the next question is, can you make a duplex repeater in the same way as a cross-frequency repeater?
Well, you can, except that the duplexing equipment is expensive. The stuff that you see up on a radio tower, that's thousands of dollars. That's why, and they have to be licensed by the FCC because of the your allowing public access to frequencies, because even though you built it for yourself, other people, if they happened upon it. So that's why the crossband repeater is a temporary solution that is mission specific. In other words, you're not really making it permanent. You can, and there are, I mean, you can go on YouTube and find any goofball in the world who's built something that he says works. And you can buy little things on eBay that allege that you can plug them in. You know where your mic, speaker mic plugs into the side of your handset, and there's typically two plugs, and one is for, you know, the speaker and one's for the mic. And there are all kinds of little concoctions that you'll see on eBay that's, you know, like $4 worth of wire, and they allege that if you plug this directly into another radio of similar kind, that it will perform that because it'll talk and receive at the same time. And they just simply don't work. They sell a lot of them because people don't know what they're doing. The other problem with that is that if you have these two radios connected by one of these, typically the cable that you would buy might be maybe 2 feet long. These antennas need to be 10 to 15 meters apart, and they should be 10 to 15 meters separated vertically. So from a practical application, it's very difficult to have a true duplexing system that's portable. There are, I mean, you could buy back in the day, and we have one. That's why I started looking at other solutions. We've got an old Kenwood mobile that had a duplexing functionality, and that, frankly, they had a big normal 12-volt deep cycle battery like you'd see in a boat, and a big mobile radio, and it traveled in a cooler, and the thing weighed 50 pounds, and you dragged it out into the field. It does work. I just think that because FCC-wise, these can't be permanent installations. So if I've got a team member sitting on a mountain peak and he's got a handheld in his hand, and he's affecting communication between field team on one side of that peak and an IC on the other side of that peak, that's exactly what a little crossband repeat functionality would provide. But be clear that one side does have to be UHF, so it wouldn't necessarily be your plain old Kenwood handset. But all of your typical VHF handsets would work off of that on the VHF side, and you could just have one handset down a command that had UHF capability, or a mobile radio that had UHF, and then push it back and forth through this handset that's up at the peak with the crossband. But that's exactly why it was designed that way. It's not practical long term, but you know, we're on a mission. So it's an interesting thing to explore from your team.
Okay, the next question is, for crossband repeaters, are both of your frequencies commercial, the one VHF and the one UHF?
Well, they are, UHF by definition is not commercial. So unless you're a licensed agency like you're running up in the 800 series like a sheriff's department. So, and this is where it gets to be interesting. If I wanted to put a full-time, I mean, I'm surrounded by mountain peaks. And if I wanted to pour a concrete pad and build a tower, I could apply to the FCC, and there's actually it's a single person in any region who's like the frequency coordinator, and I could say, you know what, I want to have these frequencies set aside for me, and then they would get published and all of that. But so when I do crossband repeat, I don't necessarily do it on the channels that are already input in my radio. You certainly can if you have one that you're not and you just say, okay, we're going to use channel 8 is going to be the VHF side of this crossband repeater because it's already programmed into, you know, 50 radios on my team or 30 radios on my team, and then that would be the VHF side. So the handset that's performing the crossband repeat functionality does have both VHF and UHF obviously built into it. These are not necessarily hyper expensive handsets. I mean, we're talking about $100, $150. And if you think of it, you would only need one to be the repeater, and then you would need UHF capability on the other end of that, and that might be a similar radio even without crossband repeat. So you could have the repeater radio, which might be $150 for the handset. You could have the UHF side if you don't typically use that. You know, keep it charged up, keep it in your command vehicle. That's maybe a $100 radio, depending on how you source it. So it's a relatively inexpensive commitment to be able to have this capability. But do keep in mind, these are kind of mission specific. You know, they're not permanent installations. But I mean, if you've got a situation developing where you've got a significant geological obstruction between command and your teams, this may be, and I'll emphasize this may be a solution for you to have effective communication in those situations. I mean, we work river rescue, not whitewater, but we do rafter rescues in canyons that are so deep, and even inside them are so convoluted, I can't talk radio to radio inside the canyon because they're so convoluted. Think of a tunnel that just twists and turns. Or I can't get into it from command if it's parked up on the highway. So these could be very effective temporary solutions to that scenario. But in order of, I kind of did the solutions also in order of practicality, in the order that you would probably want to explore it. You know, take a look at some tuned antennas, take a look at a rat tail, take a look at the roll-up J-pole, and then so that you're not investing a whole lot of money or time or expertise, but go ahead and take a look at a crossband repeater.
Okay, and kind of on the same topic. If you're cross-banding from commercial to amateur, do you have a licensing conflict?
This is why it's always important to have I believe that somebody on your team should take the time to get their technician's license. This is it's a very simple thing to get. I mean, you study the technology that you need to learn and the rules and regulations that you need to learn to get a technician level license. You could literally study for online over a weekend and take your test and get your technician's license. Because once you do step outside the commercial frequencies, federal regulations would dictate that a licensed ham operator be involved. For me, it's a pretty easy solution because I have that technician, which is the very first level, really simple level license. But that's sufficient for me then to be able to communicate on any band that I'm licensed to or any frequencies that I'm licensed to. But that's it's a good and it's an important question because we do need to follow the laws as regards to FCC. But the solution to that is, just have a couple of your ICs or whatever, take a weekend, study for the test. You can study online, and then you're good to go.
Okay. On a 5-watt handheld, how does the roll-up J-pole compare to the extendable Smiley super stick antenna in performance?
See, there's somebody who's Smiley's who I buy my antennas from. So if you've got a Smiley super stick, that's running. And if they're asked that question, they're on this webinar right now, so they can hear me. Here's the thing that I like about it. It's probably similar performance. When we look at the measurable power, that is, what number are we putting on an antenna? That little short quarter wave Smiley is running about 3 decibels. If I go to that 5/8 antenna, which was maybe 3 inches longer, but it's still under a foot, that's running 6 decibels. So because I've doubled the number from 3 to 6, I've actually quadrupled the effectiveness. The extendable super stick will run probably 6 to 9 decibels, so it's a very good antenna. The only problem is the practicality in that when that thing is fully extended, it is a wavelength long. It's 3 feet long. I just like the J-pole. It runs about the same, 6 to 9. If for people who want to get technical, it'll run 6 to 9 decibels. It'll be similar in performance. It's more of a stationary, obviously more of a stationary thing. I carry that super stick that was mentioned in my pack because it's nothing. It doesn't take a moment to unscrew an antenna, screw another antenna on. I mean, think if you're providing medical, you've come upon your subject and you're having bad, sketchy communication. It doesn't take much to pull one of those super sticks out of your pack. It's probably under $30. put it on your handset, but be advised that you now have a 3-foot piece of metal attached to that little connection on your handset, so it's very easy to break it off. So depending on what you can do, you know, if you want to put a J-pole on an extended hiking stick, if you want to hang it from a tree, but they're similar in performance. And a long story, long answer.
Okay. Do you have any suggestions for practical field test procedures for testing different antennas?
Yeah, I do, and they are all just very practical. If you've got, what I did was I bought I started small, and I bought the quarter wavelength centered at about 155 or 150. Off the top of my head, I don't really recall, but again, it's just a bell curve that we're trying to get near. So I bought a quarter wave and a 5/8 wave, and then I remember that if you're talking on a repeater, for example, if I'm standing right next to you and we're on a repeater channel and the repeater is 15 miles away, we're not talking radio to radio 3 feet away, 6 feet away. We're talking 15 miles to the repeater and 15 miles back. So in that case, it's very easy to stand somewhere and have 3 handsets, one with your stock rubber duck, one with a quarter wave, and one with a 5/8 wave, and experiment a little bit. Talk back and forth, and you should separate yourselves by 20 meters or so, just so you don't really overpower one another, because you are banging all the way to the, since you're going all the way to the repeater, you're also kind of overpowering the handset next to you with a frequency that might be pretty close to the one that it's listening for. So I would stand 20 meters apart, but I mean, this is literally, you know, take a couple of lawn chairs somewhere and set them up at a trailhead where you normally can communicate pretty well with your repeater, and take a bottle of water and 3 lawn chairs and camp chairs and sit out there and explore. I mean, it was a dramatic, I'll tell you this, it was a dramatic difference when I stood at my base and my SAR repeater is approximately 15 miles away, and there's just enough geologic obstruction that some people's handsets didn't work very well, some do, some don't. In other words, that was kind of a good spot to be because it was a little bit marginal, and the commercial accessory antennas dramatically outperformed the rubber duck that comes standard. Like I laugh that you may as well stick a potato on the top of your radio. And actually, the California Wildfire Safety Board, their protocols are replacement of those rubber ducks about once a year. They get beat up. Yeah, the difference is just astounding in most situations. But that's the easiest way to test it. Just go to somewhere where you know that your performance on the repeater is marginal and you're sitting right next to each other, so you both have to hit the repeater, and then just screw one of these smiley antennas on and see if it makes a difference. So, you know, your output is you bought a couple of antennas for, you know, $22 a piece. But that was the single thing that changed the performance of my handset the most. And then I could take that rat tail and add it to everything that was in place. So, and you can take it off and put it on. You know, it's again, I'll send Jessica kind of a list of links that you can hit, and there's a million YouTube videos, and there's a couple people that sell them. What's interesting, there's a guy in British Columbia that sells them specifically designed for the smiley antennas. So that's kind of a cool solution too. They're probably, with shipping out of BC, they're probably $28, something like that. But I mean, they're specifically designed for those smiley antennas. So that, yeah, testing is just practical. You know, there's no people. What I don't want people to do is get all caught up because they know somebody's got an oscilloscope and he's like an uber ham radio operator, and it's not the same. You're sitting in somebody's shop on an oscilloscope. It's not the same as trying to bend a radio wave down into a valley that you do missions in. So I just like to kind of be practical. Just sit on a chair and talk, switch your antennas and talk again.
Okay. And the next one is, it sounds like a cross-frequency repeater would be a one-way only transmission. How would the field mobile unit receive the base?
Well, that's where why the one that's in the middle has to have this specific capability. I have a handset I paid about $150 for. It has crossband repeater capability. And when I did the one, this is the difference between a webinar and real life. When I did this presentation live in Estes Park last June, that little ammo box was sitting in the corner, just minding its own business, because the radio's inside. If you just turn it on, plug it in, shut the top, and there's the antenna. And I had a compatriot in the back of the room with a UHF tuned to the crossband repeater, and I stood in the front with a standard VHF handset that we all carry in the field. And what happens is this: I talk VHF, it hits the repeater, and it is simultaneously transmitting in UHF. That's why you don't need this big duplexer and power supplies and all this stuff that goes on a commercial repeater up on a tower. So the radio itself is capable of incoming and output simultaneously. It just has to happen on, because you're using a single antenna and basically a single chassis inside the plastic case. They just have to be separate bands. But it is real-time, simultaneous. I talk, you hear. When you push your button on your end, I hear. It just has to cross from UHF to VHF back and forth in either direction. But it is quite literally, and it worked. I mean, it shocked people in the room. I mean, it was an interesting presentation at that meeting. People stayed for like 45 minutes, nearly an hour afterward with questions, because this is such a universal problem for us in the field. And I mean, I was up against the barbecue, and so they were interested. But yeah, their minds were blown when I keyed up my standard VHF frequency handset, and it was simultaneously coming out UHF on, it just happened to be the back of the room. But no, this is real-time, simultaneous, duplex communication is what we call it. It just has to go VHF to UHF unless you've got a big repeater on a tower.
Okay. And it looks like the last question here is, some of the radios from China offer 7-watt output. Are these legal?
Some of the, I want to thread a needle here a little bit. Some of, you're seeing 7 watts, you're seeing 8 watts. Specifically, we're talking about a couple of models of Baofeng. When you buy the Chinese radio, I mean, the most popular one in the world is that 5VR. It's a Baofeng. You can buy them on Amazon nowadays for like $22. I can tell you this though, when I was running because I was monitoring all frequencies. I had like chest pack galore on this El Paso County Search and Rescue research last week, so I could listen to. They're using 2 different channels on the field, ops and tactical. They're talking to IC on yet another frequency when they need to. And I can tell you that I could have at the end of a debrief closed my eyes and said, who was top on that exercise? You've got a Baofeng. Who was this? You've got this. I'm not a big fan of Baofeng only for this reason. There are a gazillion counterfeit ones out there. So it's either old technology, old firmware. Sometimes they buy up in bulk the ones that didn't pass QC, and they repackage them and they call them a slightly different number, like a 5VR-2GT, and they come in a yellow case instead of that. There's a lot of counterfeit stuff out there. If you'd like, I have no argument with the radios. They're good radios. I happen to use Anytone. It is a Chinese radio. It's slightly more expensive, but the front end is hyper quality. But I mean, those Chinese radios are out there. They're just fine if you don't get a counterfeit one. And they're not that much more expensive to buy a real one. You just have to be careful where you buy it from. And if it would be helpful, I'll do the best I can to provide Jessica with who I believe are legitimate Baofeng dealer in the U.S. I mean, there's a couple that have, I mean, they've got a presence in Texas and all this, and, try and get some work done on them, or try and get an answer. Or I guess if you got a $25 radio, you don't send it in for service, you throw it away. But there's a lot of counterfeit Baofeng out there right now. I guess would be my only thing. Otherwise, the 7-watt thing, I mean, they're selling them. If they're stickered by the FCC, they're stickered by the FCC. I mean, I'm not going to I'm not going to pretend that I'm an FCC lawyer. I know that some of these radios that came out were, they could do, this was an interesting thing. They could do VHF, UHF, which makes it a ham radio handheld, but they could also do FSR, which was or FRS, which was a family radio service, like you could buy at Cabela's if you're going goose hunting, you know. And then there's but that wasn't legal, and so they got completely shut down. You know, the radio can be built to do it, but it wasn't legal, so they got completely closed down. On that note, it's not a bad idea to have a couple of these ones that you buy from Cabela's in your command vehicle, because guess what? If I'm out here looking for elk hunters, they may very well be communicating on that little handheld that they bought at Cabela's. And so if I've got one in my truck, you know, maybe I can talk to them, maybe I can hear them. So don't tie it all to your handset that you carry for team, you know, team member to team member or team member to IC communication. But yeah, I mean, technically, if it's offered for sale in the U.S. and it's been stickered properly, I'm not going to play lawyer on that. I will say this, that the wattage is not logarithmic. So that's, think of that as straight line. So for me to go from 5 watts to 7 watts is kind of like, I'd rather spend the money on a better front end. In other words, better technology in the case, and I'd rather spend the money on an antenna. I can dramatically outperform even an illegal 10-watt handheld with a decent antenna on a plain old handheld.
Okay, that looks like all of the questions. So let me go ahead and switch this over to my screen, and I will kind of wrap this up. Alrighty, so if you have further questions, you can email Paul at the email shown on the screen, and like we said a few times, we will put a source list up on the website that you can access. And we host webinars frequently with this MRA webinar series, so you can keep an eye on the PMI and MRA websites, and also the MRA lister as places where you can hear about future dates and topics. And the recording of this webinar, the presentation slides, and also the source list from Paul will be available on the MRA and PMI websites shown at the bottom or middle of your screen there. And for news and updates, you can follow PMI and MRA on Facebook and Twitter at the URLs shown on your screen. And we thank you for attending, and we hope it was helpful. And thanks, Paul, for presenting it.
My pleasure. Happy to be here.
All right. Have a great day, everybody.